Hello everybody. Today we're going to look at solving systems by elimination. We recently learned how to solve systems of equations by substitution. Today we're going to learn another algebraic method that works in situations where substitutions might be a little bit messy. Let me show you an example. Let's solve 3x minus 4y equals 11 and negative 3x plus 2y equals negative 7. Now, if we wanted to use substitution here, we would end up with something a little bit messy because all of the variables have coefficients. So if we wanted to isolate any of these variables, we would need to divide by the coefficient, and we would end up with fractions. We would end up with quite a lot of fractions. And we would prefer to avoid those if we can. So this other method, elimination, works really well, especially in this problem. Here's what we're going to do. I'm going to take the two equations and I'm going to stack them on top of each other. I'm going to write 3x minus 4y equals 11. And then below that, negative 3x plus 2y equals negative 7. And what I'm going to do is I'm going to take the left-hand sides and add them together, and the right-hand sides and add them together. This is something that we are allowed to do. Now, I'm going to write this big addition sign. This is my own notation. This is not something that other instructors do. I just like to write this to show we're taking this whole equation and adding it to this whole equation, the left sides and the right sides. Now, the reason we're allowed to do this is because in an equation, the left and right-hand sides are equal to each other. So what we're really doing is we're taking this first equation and we're adding equivalent quantities to both sides. We're effectively adding the same thing to both sides. Even if that same thing looks a little bit different, we know that they're equal to each other. Now on the left, if we add 3x plus negative 3x, that gives us no x's. They actually cancel, and the variable x is eliminated. That's why we call it elimination. We can sometimes eliminate a variable by adding the equations together. Now let's look at the y's. Negative 4y plus 2y is negative 2y. And then we have equals. The equals always need to stay lined up. On the right, 11 plus negative 7 is 4. So we've got negative 2y equals 4. We've eliminated the x. Now to solve for y, we just need to divide both sides by negative 2. And when we do that, 4 divided by negative 2 is negative 2. So we have y equals negative 2. We're not finished. We need to solve for x. And to do that, just like the last lesson, we can take this value for y and substitute it into any of the equations that have both x and y. I'm going to pick this first equation because the goal now is going to be solving for x, and I'd rather have a positive coefficient on the x instead of a negative. But either one would work. So we've got 3x minus 4y equals 11. But we know that y is negative 2, so we can substitute in negative 2 for the y. Now, negative 4 times negative 2 is positive 8, so this is going to turn into 3x plus 8 equals 11. We want to get the x alone. We can subtract 8 from both sides. That gives us 3x equals 3. And if we divide by 3, that gives us x equals 1. So we have our solution, y equals negative 2, and x equals 1. And we're good to go. Let's take a look at another problem. This one is going to have an extra step. I think at this point you know me pretty well. I start off with the most basic version, and then we get into some that are a little bit more complicated. Let's take a look now. Let's solve the system 4x minus 5y equals 13 and 2x equals 7 plus 3y. Now there's two things that we're going to have to do a little bit differently with this problem. First, we're not going to stack them up right away, specifically because here the x and the y are on the left-hand side, but here the x is on the left and the y is on the right. We want to get everything lined up so that the like terms can be added together and so that one of the variables can cancel to get eliminated. So what we're going to want to do is bring this y to the left-hand side so that it matches the other equation where we've got the x and the y on the left. To do that, we're going to subtract 3y on both sides, and this gives us 2x minus 3y equals 7. Now, we're not going to just stack them and add them now, because if we did that, nothing would cancel. We've got 4x and 2x. If we add those together, we get 6x. Negative 5y minus 3y gives us negative 8y. And so here, neither of them is going to cancel. And our goal is to have one of the variables cancel so that it is eliminated. So we're stuck. We're going to have to do something different here. Now, our goal is to get one of the variables to eliminate, to cancel. And I want to take a look at this x here. We've got 4x. What term would we need to add to this to make the x's cancel? Now the answer is negative 4x. If we had a positive 4x and a negative 4x, those would cancel. So what we really want, I'm just going to write here, we want a negative 4x. How can we get a negative 4x in this other equation? What can we do to 2x to turn it into negative 4x? The answer is we can multiply it by negative 2. But we know if we multiply one side of an equation by negative 2, we also have to multiply the other side by negative 2. So here, we're going to multiply both sides by negative 2. Let's see what that gives us. Negative 2 times 2x is negative 4x. Negative 2 times negative 3y is positive 6y. And 7 times negative 2 is negative 14. By multiplying both sides by negative 2, we now have the negative 4x that we wanted, which is going to cancel with this positive 4x. So now we can stack them. 4x minus 5y equals 13. And negative 4x plus 6y equals negative 14. Now we can add them together. Negative 4x plus negative 4x is 0. Those cancel out. The x is eliminated. Negative 5y plus 6y is just 1y, or y. And 13 plus negative 14 is negative 1. So we've got y equals negative 1. Now we need to solve for x, so we need to substitute this into any of the equations with x and y. I think the easiest one is going to be this one. 2x equals 7 plus 3y. I'm going to write that down here. And then I'm going to substitute in negative 1 for y. This gives me 2x equals 7 plus 3 times negative 1. 3 times negative 1 is negative 3. And 7 plus negative 3 is 4. So we get 2x equals 4. And if we divide by 2, x equals 2. So our solution here is going to be y equals negative 1 and x equals 2. All right. I want to, again, write out the step-by-step instructions for elimination so that you have a list of instructions that you can follow if that helps. So here we go. All right, first we want to write both equations in standard form, ax plus by equals c. That's what we did up here. We subtracted 3y from both sides so that we could get the x and the y terms on the left and the constant on the right. Then, if necessary, multiply one or both of the equations so that one pair of terms has opposite coefficients. That's what we did here. We multiplied this equation by -2 to give us a -4x, which is the opposite of the positive 4x we had there. After we've done that, we can add the two equations together, solve for the first variable, substitute that into one of the original equations with both variables, and then solve for the second variable.